Hi there! Welcome to Mathematics Alive Algebra Lesson 30, Graphing Quadratic Equations in Two Variables. The equation y is equal to ax squared plus bx plus c, where a, b, and c are real numbers, is a quadratic equation in two variables. Parabola. The graph of the equation y is equal to ax squared plus bx plus c is a parabola. The vertex of the parabola has an x-coordinate of x is equal to negative b over 2a. Here are the characteristics of the parabola. A. The vertex gives the minimum value of y when a is positive. And this parabola opens up and can be classified as concave up. Letter B. The vertex gives the maximum value of y when a is negative. And this parabola opens down and can be classified as concave down. Letter C. The line of symmetry is at x is equal to negative b over 2a. And this is the line of symmetry, this blue line, which passes through the vertex of the parabola. Letter D. The x-intercept is at y equals 0. And letter E. The y-intercept is at x equals 0. If the parabola has no x-intercepts, it does not touch the x-axis. Let's do the graphs.
We will be graphing parabolas today. Example number 1, we have y is equal to x squared plus 2x minus 3. The first thing that we have to find is the vertex of the parabola, which gives us either the highest point of the parabola or the lowest point. But in this case, we have a positive a. The value of a is equal to 1 and the value of b is equal to 2. Since we have a positive value of a, we expect that the parabola will be going upward. And the x value of the vertex is equal to negative b over 2a or negative 2 over 2 times 1 or negative 1. So we have vertex at negative 1 and then we solve for y. So substituting the value x is equal to negative 1 in this equation, we have negative 1 quantity squared plus 2 times negative 1 minus 3. So we have y is equal to 1 minus 2 minus 3 is equal to negative 4. We can locate now the vertex of the parabola. Negative 1, negative 4. Negative 1 is here, negative 4 is here. So the intersection of the two, we have negative 1 and negative 4, is this point. Vertex at negative 1, negative 4. And then we also indicate the line of symmetry at the x value of the vertex. The line of symmetry will guide us to locate the other points of the parabola. The next points that we will locate are the x-intercepts at y is equal to 0. So we set y is equal to 0 in this equation. 0 is equal to x squared plus 2x minus 3. Then we factor x plus 3x minus 1. Then solve for x. We have x plus 3 equals 0, or x minus 1 equals 0. So x is equal to negative 3, or x is equal to 1. And our value for y is 0. So we have negative 3, 0, and 1, 0. So these are our x-intercepts. So we will locate those points. Negative 3, 0 is here, and 1, 0 is here. Okay, but we have some points in between which should be located so that we will have a smooth graph. So we can take a point at x equals 0, and when we're solving for x equals 0, we simply cover this 0, 0. So y is equal to negative 3. So at x equals 0, y is equal to negative 3. And then we can reflect the value at 1 unit away from the line of symmetry to the left. So we have 1 unit, there is 1 point here, and another unit here. We have another point here, which is negative 2, negative 3. And this one is 0, negative 3. Now we can graph the parabola. We have the vertex here. We have to connect the points with a curve, because if you connect it with straight lines, it will not be a parabola. And then if you want a smoother parabola, and if you want to extend that, then you can add more points. But at the moment, we have already the shape of a parabola. If you add more points, like if you add x is equal to 2 and x is equal to negative 4, you will have a point on the higher part of the coordinate system. So let's try at x is equal to negative 4. So y is equal to negative 4 quantity squared plus 2 times negative 4 minus 3. And this is 16 minus 8 minus 3. So we have 8 minus 3 is equal to 5. So we can add another point here, negative 4, 5. And then we can reflect this point to the other side of the parabola. So this is 3 units away from the line of symmetry. So we can have another point here reflected 3 units away from the line of symmetry. And we have another point here. This is negative 4, 5, and this one is positive 2, 5. There you have it, a parabola going upward. Example number 2, y is equal to negative x squared plus 6x minus 5, where a is equal to negative 1 and b is equal to 6, and our vertex will be at x is equal to negative b over 2a, so negative 6 over 2 times negative 1. So we have positive 3. So this is our x value for the vertex, and then we solve for y. So solving for y, we have y is equal to negative x squared plus 6x minus 5. So we substitute the value 3. So y is equal to negative 3 quantity squared plus 6 times 3 minus 5. And y is equal to negative 9 plus 18 minus 5. Remember that you are only squaring the number inside the parentheses, and the negative sign is not included in the squaring process. So this is still negative 9. And y is equal to 9 minus 5. So y is equal to 4. This is our vertex. We will locate our vertex in the graph. So 3, 4, 3, and then 4 here. Okay, and then since we have negative value for a, we expect that the graph is going downward. And we can already draw the line of symmetry, because the line of symmetry is at the value x is equal to 3. So I'll just draw the line of symmetry to enable us to look at the symmetry and make the line or make our graph symmetrical. So this line is x is equal to 3. Then our next points will be the x-intercepts. We solve for the x-intercepts at y is equal to 0. So we set y is equal to 0, and then minus x squared plus 6x minus 5. We will multiply both sides by negative 1 to make this positive. So that is 0 is equal to x squared minus 6x plus 5. And this is factorable, so we factor x minus 5 and x minus 1 to get a negative 6 in the middle term. So equating this to 0, x minus 5 equals 0, or x minus 1 equals 0. Therefore, x is equal to 5, or x is equal to 1. So our x-intercepts are at 1, 0, and 5, 0. And we can locate that. So 1, 0 is here, and 5, 0 is here. Okay. Then we can find some other points to make the graph smooth. We can look for the value at x is equal to 2. Then we solve for y at x is equal to 2. Y is equal to negative 2 squared, 4, plus 6 times 2, 12, minus 5. So y is equal to 12 minus 9. So y is equal to 3. And the point is 2, 3, 2, 3 here. And we will just reflect another point here, 1 unit away from the line of symmetry. So we have another point here at 4, 3. Okay. And we can start graphing. And we have to locate some more points to make the graph smooth downward. So we can have another point here at x is equal to 0. At x is equal to 0, we simply cover this 0, 0. So you have negative 5. So 0, negative 5 is here. And we can connect the points. And since this is 3 units away from the line of symmetry, we can reflect another point here 3 units away from the line of symmetry at 6, negative 5. And we have a very smooth graph of our equation, a parabola going downward. Example number 3, we have y is equal to 2x squared minus 8x plus 9. So a is equal to 2 and b is equal to negative 8. So our x value for the vertex is at x is equal to negative of negative 8 over 2 times a, or 2 times 2. So positive 8 over 4 is equal to 2. Okay. Then we will solve for the y value. So y is equal to 2 times 2 squared, or 4, minus 8 times 2 plus 9. So we have 4 times 2, 8, minus 16 plus 9. So we have negative 8 plus 9 is equal to positive 1. Value here is 1. We can locate the vertex at 2, 1. 2, then 1. We see here that the graph is going upward because the A is positive. So we expect that the graph will go this way. And we have to locate the line of symmetry. At x is equal to 2. Then, again, let's locate the x-intercepts at y is equal to 0. So, we set y is equal to 0, and then we copy the right side of the equation, 2x squared minus 8x plus 9. So, 0 is equal to, I think this will be harder to factor, so we will use quadratic formula. Using quadratic formula, we have x is equal to negative b, negative of negative 8, plus or minus the square root of b squared, negative 8 squared, minus 4, a, c, all over 2 times a. And so our x is equal to positive 8 plus or minus the square root of 8 squared, 64, minus 8 times 9, 72 over 4. But since we have something here which is negative, the value inside the radical sign will be negative. Okay, so we have 6 plus 2, negative 8 all over 4. And this gives us an imaginary answer. Therefore, there will be no x-intercept. So, the only option is for us to get neighboring points of our vertex. There will be no x-intercept because the graph is going up. It will not touch the x-axis. So, let's look for neighboring points to the left of the line of symmetry, and we will assign points at 1, 0, and negative 1, perhaps. Let's try 1 and 0 first. So, at x is equal to 1, we have y is equal to 2 times 1 squared, or 2 minus 8 plus 9. So, we have 11 minus 8 is equal to 3. So, 1, 3 is here. And we will simply reflect another point to the right. So, we have another point here, which is 3, 3. And here we have 1, 3. And we can shape the parabola. And then we have another point at 0. At x equals 0, we simply cover this, 0, 0. And you have y is equal to 9. So I will add this 0.33. So 0.9 is here, and this is 2 units away from the line of symmetry. So we will reflect another point here, which is 2 units away to the right of the line of symmetry. So this is at 4, 9. So we have 0, 9 and 4, 9. And then I'll just connect these points. And put an arrow indicating that this graph will go upward indefinitely. And we have our parabola. If you think this video had been helpful to you, please don't forget to like, share, and subscribe to this channel by clicking the button below. Thank you very much for watching, and God bless. Take care. Bye-bye.